rule of thumb stating 12 outlets for a 15 amp circuit and 16 for a 20 amp circuit is not entirely accurate. It's an oversimplification. Several factors influence the maximum number of outlets you can safely connect to a circuit. Firstly, the circuit amperage is a primary factor. A 15 amp circuit can handle less total power than a 20 amp circuit. Secondly, the type of outlets matters. Standard 15 amp outlets are different from heavy-duty 20 amp outlets, each affecting the overall load. Thirdly, the total circuit load is critical. This is the amount of power being drawn by all connected devices. It must not exceed the circuit's amperage rating. Fourthly, appliances and lighting impact the load. The presence of appliances, fans, motors, and lighting fixtures significantly affect how much power a circuit is using. For example, a calculation might have resulted in approximately 12 outlets for a 15 amp circuit because it assumed no appliances or other devices were connected. But adding even a few devices can quickly overload the circuit. While there is no absolute hard and fast rule, a general recommendation is to limit the number of outlets on a 15 amp circuit to between 10 and 12, and on a 20 amp circuit to between 15 and 18. This provides a safety buffer for occasional heavy loads and helps prevent circuit overloads. There are additional considerations to be aware of. Firstly, circuit length matters. Longer circuits have increased resistance, which can reduce the voltage available at the outlets. Secondly, wire gauge is important. The gauge of the wire used for the circuit affects its current carrying capacity. Thicker gauge wires can handle more current. Thirdly, ground fault circuit interrupters, or GFCIs, can require additional outlets on a circuit. Never exceed the maximum amperage rating of a circuit. Overloading a circuit can lead to overheating, electrical fires, and damage to appliances. If you are unsure about the load on a circuit, it's always best to consult with a qualified electrician. To understand this better, let's delve a little deeper into each of these factors. Looking at circuit amperage, remember that a 15 amp circuit at 120 volts can theoretically supply 1800 volt amps, which is 15 multiplied by 120. 20 amp circuit at 120 volts can theoretically supply 2400 volt amps, which is 20 multiplied by 120. However, it's crucial not to load a circuit to its maximum theoretical capacity. The National Electrical Code, or NEC, typically requires continuous loads to be limited to 80% of the circuit's rating. This means a 15 amp circuit should not have a continuous load exceeding 12 amps, and a 20 amp circuit should not exceed 16 amps. This 80% rule is a safety margin to prevent overheating and potential fire hazards. When assessing the type of outlets, bear in mind that while standard duplex receptacles are generally rated for 15 amps, you can also find 20 amp receptacles. The configuration of the slots on a 20 amp receptacle is different, featuring a T-slot that accepts a 20 amp plug. If you are installing 20 amp receptacles, it's essential to ensure the entire circuit, including the wiring and breaker, is also rated for 20 amps. Regarding circuit load, this is where careful calculation is necessary. Every device plugged into an outlet draws a certain amount of power, measured in watts. To determine the load on a circuit, you need to estimate the total wattage of all devices that are likely to be used simultaneously. For example, a lamp might draw 60 watts, a television 150 watts, and a computer 300 watts. Add up the wattage of all these devices to get the total load. Then, divide the total wattage by the voltage of the circuit, typically 120 volts, to determine the current in amps. This calculated current must be less than the maximum allowable current for the circuit, taking into account the 80% rule. The presence of appliances and lighting introduces further complexity. Some appliances, like refrigerators or microwave ovens, draw a significant amount of power. These appliances should ideally be on their own dedicated circuits to avoid overloading general-purpose circuits. Lighting can also contribute significantly to the load, especially if you have multiple high-wattage incandescent bulbs. Consider using LED lighting, which consumes far less power than traditional incandescent bulbs. The recommendation to limit the number of outlets provides a practical safety margin. Even if you don't know the exact wattage of every device that might be plugged in, limiting the number of outlets reduces the likelihood of overloading the circuit. This is particularly important in residential settings where occupants may not be aware of the circuit's capacity. Focusing on circuit length and wire gauge, longer circuits experience voltage drop. This means the voltage at the end of the circuit can be lower than the voltage at the beginning. This can affect the performance of devices plugged into those outlets. To minimize voltage drop, use thicker gauge wires for longer circuits. The NEC specifies minimum wire gauges for different circuit amperages and lengths. Consult NEC Table 310.15b16 for opacities of insulated conductors. Ramfall circuit interrupters, or GFCIs, are designed to protect against electrical shock. They detect even small imbalances in current and quickly trip the circuit. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. While GFCIs do not directly impact the number of outlets you can have on a circuit, it's essential to include them in your overall electrical plan for safety reasons. Always prioritize safety when working with electricity. Overloading a circuit is a serious hazard that can lead to overheating, electrical fires, and damage to appliances. If you are ever unsure about the load on a circuit or the proper wiring methods, consult with a qualified electrician. They can assess your specific situation and provide tailored recommendations. The NEC provides comprehensive guidelines for electrical installations. Familiarize yourself with the relevant sections of the code to ensure your electrical work is safe and compliant. Calculating the load on a circuit involves several steps. Firstly, identify all the devices that will be connected to the circuit. Secondly, determine the wattage of each device. This information is usually printed on the device's nameplate. Thirdly, add up the wattage of all the devices to get the total load. Fourthly, divide the total wattage by the voltage of the circuit, typically 120 volts, to determine the current in amps. Fifthly, compare the calculated current to the maximum allowable current for the circuit, taking into account the 80% rule. If the calculated current exceeds the maximum allowable current, you need to reduce the load on the circuit by either removing devices or moving them to a different circuit. Understanding the concepts of voltage, current, and resistance is fundamental to understanding electrical circuits. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of electrical charge. These three quantities are related by Ohm's law, which states that voltage is equal to current times resistance. A deeper dive into wire gauges can reveal more information. Wire gauge is a standardized measurement of wire diameter. The smaller the gauge number, the thicker the wire. Thicker wires have lower resistance and can carry more current without overheating. The NEC specifies minimum wire gauges for different circuit amperages. For example, a 15 amp circuit typically requires 14 gauge wire, while a 20 amp circuit typically requires 12 gauge wire. However, for longer circuits, it may be necessary to use even thicker gauge wires to minimize voltage drop. Consider the scenario where you have a 15 amp circuit in a workshop. You plan to connect a power drill, a work light, and a radio to the circuit. The power drill draws 6 amps, the work light draws 2 amps, and the radio draws 1 amp. The total current draw is 9 amps, which is below the maximum allowable current of 12 amps for a 15 amp circuit, adhering to the 80% rule. In this scenario, you could safely connect all 3 devices to the circuit. Now consider a different scenario where you have a 20 amp circuit in a living room. You plan to connect a television, a game console, a sound system, and a lamp to the circuit. The television draws 3 amps, the game console draws 2 amps, the sound system draws 4 amps, and the lamp draws 0.5 amps. The total current draw is 9.5 amps, which is below the maximum allowable current of 16 amps for a 20 amp circuit, adhering to the 80% rule. In this scenario, you could safely connect all 4 devices to the circuit. However, if you were to add a space heater that draws 10 amps to this same circuit, the total current draw would be 19.5 amps, which exceeds the maximum allowable current of 16 amps. This would overload the circuit and could potentially trip the breaker. Therefore, it would be necessary to either remove the space heater or move it to a different circuit. The placement of outlets can also influence how you load a circuit. If you have a long wall with multiple outlets, people are more likely to spread out the load across those outlets. But if you have a cluster of outlets in one location, people may tend to plug multiple devices into those outlets, potentially overloading the circuit. This is why it's important to consider the intended use of the space when planning the layout of electrical outlets. Furthermore, different types of devices have different power requirements. Some devices, like computers and televisions, have a relatively constant power draw. Other devices, like power tools and appliances with motors, have a surge of current when they are first turned on. This surge can be several times the device's normal operating current. It's important to account for these surge currents when calculating the load on a circuit. One way to mitigate the impact of surge currents is to use a device called a soft starter. A soft starter gradually increases the voltage applied to the motor, reducing the surge current. These are more typically seen with larger motors. Soft starters are often used with large motors in industrial applications. In residential settings, it's generally sufficient to simply be aware of the potential for surge currents and avoid overloading circuits with multiple devices that have high surge currents. The color of the wire insulation is also significant. In North America, black wires are typically used for the hot conductor, white wires are used for the neutral conductor, and green or bare copper wires are used for the ground conductor. The hot conductor carries the current from the power source to the device. The neutral conductor returns the current from the device to the power source. The ground conductor provides a path for fault current to flow back to the power source in the event of a short circuit, protecting against electrical shock. The size of the electrical box is also important. The electrical box houses the wiring connections and protects them from damage. The NEC specifies minimum box sizes based on the number and size of the wires and devices contained within the box. Using an undersized electrical box can lead to overheating and potential fire hazards. In addition to the number of outlets on a circuit, it's also important to consider the spacing of outlets. The NEC specifies minimum spacing requirements for outlets in residential dwellings. These requirements are designed to ensure that no point along a wall is more than a certain distance from an outlet. This makes it convenient to plug in lamps and other devices without having to use extension cords. In general, outlets should be spaced no more than 12 feet apart along a wall. This means that no point along the wall is more than 6 feet from an outlet. There are also specific requirements for outlets near doorways and in hallways. And consider dedicated circuits. Certain appliances, such as refrigerators, washing machines, and electric dryers, require dedicated circuits. A dedicated circuit is a circuit that serves only one appliance. This prevents these high-power appliances from overloading general-purpose circuits. Dedicated circuits are typically required for appliances that draw a significant amount of power or that operate continuously. The use of power strips and surge protectors is also common. Power strips provide multiple outlets in one location, making it convenient to plug in multiple devices. However, it's important to ensure that the power strip is rated for the total load of all the devices plugged into it. Surge protectors protect electronic devices from voltage spikes. Voltage spikes can damage sensitive electronic components. Surge protectors work by diverting excess voltage to ground. It's important to choose a surge protector that is rated for the appropriate voltage and current. A multi-wire branch circuit is another wiring configuration. A multi-wire branch circuit shares a neutral conductor between two hot conductors. This can save on wiring costs and reduce voltage drop. However, multi-wire branch circuits must be properly wired to avoid overloading the neutral conductor. The NEC specifies requirements for multi-wire branch circuits. Furthermore, arc fault circuit interrupters, or SAIs, are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating heat that can ignite nearby combustible materials. SAIs detect these arcing faults and quickly trip the circuit. SIs are now required in many areas of the home, including bedrooms, living rooms, and dining rooms. The proper grounding of electrical systems is also essential for safety. Grounding provides a path for fault current to flow back to the power source in the event of a short circuit. This protects against electrical shock and prevents damage to appliances. The NEC specifies requirements for grounding electrical systems. Finally, always remember to turn off the power before working on electrical circuits. This prevents electrical shock. Use a voltage tester to verify that the power is off before touching any wires. Follow all safety precautions when working with electricity.